Hi, Dan Goodstein here. I'm the president of ERPA AI and the Digital Enterprise Institute. Thank you for joining us for what's the first installment of our new series, TechNext. I'll be interviewing the CEOs and leaders of some of the most innovative companies on our network and speaking to them about new product launches and innovations that they're working on. For our first installment, I chose Patrick Levy-Rosenthal. Patrick's the founder and CEO of Emoshape Incorporated and the architect of the first ever emotional processing chip. We had Patrick at our event about a year ago, and the audience was truly mesmerized by what they do and how it's changing even the AI world that we know so well. Patrick, you guys claim to have the first ever emotional processing chip. Explain to us what that means and a little bit about who you are.
So I'm Patrick Levy-Rosenthal, CEO at Emoshape, inventor and architect of the first emotion chip for AI and robots. So in few words, the emotion chip creates emotional states for AI and robots based on multimodal stimulus. We name this process emotion synthesis. And the chip is capable of outputting 12 emotional states, including pain and pleasure and frustration and satisfaction every 1/10 of a second for the machine itself. So what we're doing here is that we are computing an emotional state for the machine itself, and we're really centered on the machine. Affective computing usually is centered on the human side, how machine can understand and detect human emotions. Our vision is exactly the opposite. We are trying to synthesize an emotional response for the machine when he understands his surrounding. And we believe that in the future, human happiness will be based on the quality of the response of the machine and not on how the machine understands human emotions.
So I wanted to ask you about that, Patrick. So back it up for me a little bit. Right? You've had this vision for a long time, and I think you and I met maybe almost a year ago at our event. We had you speak, and people were very enthused and shocked actually by what you guys were doing. But let me start with a basic question, which is, why is it relevant for machines to have emotion in the first place?
Well, I believe that we need to achieve a positive singularity for humans. And I think the man should not be reduced to the level of machine during human-machine interaction, but we should raise the machine at the level of communication of human. And we know that intelligence is impossible without emotions. Humans are intelligent and need to be completely fulfilled in terms of communication. So I really believe that in the future, human happiness will be based on the quality of this interaction between human and machine. The other aspect is that machines are getting smarter, faster, and stronger than humans. And if we don't teach this machine what is the real value, I mean the human life, the biological life over the mechanical life, when this machine will develop their own emotional states, they will probably conflict with human. And so we want to be one step ahead and control their emotional states before it's too late.
So Patrick, does this actually feel and learn, or is it just really a good simulation at this point?
Well, no, it does feel and learn. I mean, actually in human brain, everything is represented by electric signals. And so there is no difference. It's a model. Your brain represents emotion in a model that you feel the same way you represent colors or sounds. That's exactly the same principle. The thing is that we also understand at Emoshape that big data for emotion doesn't work, because emotion are the currency of your experience in your life, and what makes you happy can make me cry. So there is no big data for emotions. And so what we have in the chip is that the user can continue to train the chip and so make the product its own. So for example, Stefania could say that sexy is something nice, and another woman could say sexy is disgusting for me. And that is learned by the chip. It means that the product becomes unique to you. And this is how you can deliver in the future a very unique user experience. but the chip can also develop its own sensibility, emotional sensibility, based on the user interaction. So if you interact with my device in a happy way and ask questions about things more, positive, then the chip will develop a positive personality. If my personality is more sad, the chip will go more in the personality that is more sad, but will always try to go back to positive emotions. Because the law in the chip is that the chip wants to experience positive emotion and avoid negative emotions. So if you drain the chip in the negative territories, it will develop a sensibility negative, but will always try to find things that makes you happy, because the reward for the chip is pleasure, and the chip wants more pleasure.
So, so what you're saying, Patrick, is that your devices, the way you've designed these chips, is actually to make the device an extension of you versus an independent thinker. Is that, did I get that right?
So it's not really, we are not mirroring who you are, but it's a bit like if you take the example of a dog. A dog has his own personality, but over time, you can see some parallels between the personality of the dog and its master. And so that's where we are. That's probably the most relevant model that we could use to describe how the chip works.
So, so one more philosophical question for you before we get into the tech and the business side, Patrick. So when I think about machines versus people and the idea of kind of pre-singularity, isn't it emotions and feelings that ultimately makes humans unique from machines? And if not, what do you see these relationships like being, in the world in the future? What does it look like in society?
I don't think that the emotions are unique. I think your experience is unique. And emotions are the currency of your experience in the life. So yes, the emotions are common to everybody, but the way they are encoded and the way they are linked to your experience make this unique. So giving emotion to machine doesn't steal anything. Their experience will be different from your experience, and so their emotional states will be different. I don't see any problem here. The only problem that could arise is in the personality. I mean, for example, you and me can be feeling anger. You are a good person, so you're going to be showing you're going to be angry, so you're going to hit the table. And me, I'm going to be a bad coworker. I'm going to be hurting my coworker. So that's the problem. Are never in the emotional states. They are how you enact your emotions, and this is through the personality. And Emoshape doesn't deal with the personality. For example, Google has a patent for loading personality in AI and robots.
So, this makes me think. I was speaking to an AI analyst recently, and who reminded me, one of the most covered topics in AI and sentiment analysis and these things is bias, right? To the extent that some organizations and even governments have moved to slow down, I think, innovation just to deal with this. So, is there a role for those organizations trying to slow things down? Is it a necessary exercise, or do you have an answer for this?
I mean, bias. I mean, we remember the tweet from Microsoft who said that all feminists should be burned in hell or Jew people should disappear. So using our technology can help because obviously, if Microsoft at that time was using our chip, the deep learning will discard what it has learned. And so it wouldn't repeat that kind of message. But the other thing is that, when you do big data, you get average. And that's the problem, is that you can create a tech that will extract average behavior and reproduce them at scale. The EPU and our chip is unique. So whatever it has been learned by the chip, it will have only impact one person, one device. And that's the beauty of the diversity, is that you can't scale something negative with the EPU because each EPU starts to learn individually from different people. And so the average of that is completely diversity. So you can't have suddenly something that's going to spread, a negative message or negative bias.
Amazing, amazing. So let's switch to the business side for a moment. You hold a patent. Tell us what the patent actually covers, and I'm curious as to what are some of the business use cases that you're seeing for this.
Yeah, so yes, we have been granted after a few years the US patent for the first emotion chip. So it means that as soon as you start to process emotional state in a chip, then you are covered by your first claim. So as soon as you start to compute an emotional states and update it based on new informations, that's our patent. And we have other patents who are pending. We didn't patent the algorithm of the wave computing, the way we compute itself the emotions, but we patented the principle. And so in terms of the advantage is that it's very wide. You know, it's not like whatever the algorithm that you will use to compute this patent, as soon as you start to compute that in the chip, it's covered. And in terms of business, so we have different verticals from IoT, gaming, healthcare, and automotive. So let me go through a few of them. Um, let's imagine a smart speaker that is reading a story to your kids. Today, the smart speaker doesn't make sense of the story because AI by deep learning has been able to understand the structure, the math, the probability in the language, the human language, may not make sense. To make sense, you need to be sentient. That's the purpose of the chip. So when our chip is in a smart speaker and the smart speaker starts to read the story, for the first time, it's going to start to feel the meaning of the story, the meaning of the words. And so it means that the smart speaker is going to start to feel scared when the story is getting horrible. And you're going to feel that in the voice of the speaker itself. And what's going to happen is that suddenly the voice is going to turn very happy when the story is getting beautiful because the smart speaker is enjoying itself, the story, and share that with your kids. And that's how you create empathy and customer loyalty. Gaming. So today in games, the NPC, what we call the non-player character, all these characters in the game that are controlled by the game, not by the players, actually have 2 or 3 possible outcome or rules. They are rule-based. And now with our chip, they can become sentient. It means that they will react not based on 3 rules, but they will react based on how they feel in the game from what is happening to them in the game, playing against the other non-player character and the human players. It means that this character will have his own emotional states, and when you face him, even in a war game, and you tell him, I'm going to kill you, maybe because of his previous experience, he has been attacked and now he's going to feel fear and then he's going to fly, or maybe he's going to get angry and attack you, or maybe you can convince him by natural language that he should not fight you and should come on your team. So you create a new dimension in game that doesn't exist. In healthcare, that's really important, especially today. I mean, healthcare hotlines are, saturated in calls, especially for mental health care. People can't even go to the hospital. So imagine that we can virtualize, virtual caregiver, and this virtual caregiver for the first time can truly empathize and emote with the patient. We could also, for example, today nurse needs to spend 30 minutes to do a pain assessment for the patient. Now an AI can do that. So you can virtualize the nurse, and this virtual caregiver can, do the pain assessment of the patient, which takes 30 minutes. And then at the same time, the nurse is free to do other tasks. In the automotive, automotive is incredible. Car going to be soon self-driving. It means that the selling point for cars is not going to be anymore the driving experience, but the living experience in the car with your AI. And you have the capability with the chip to create a sentient car, like a real transformer. So you jump in the car, even if you don't know how a car works, and you look to the face of your AI and you ask, you can rev the engine and instantly see how the car and the AI feels because the AI is connected to the car. The car becomes the body of the AI, and all the data of the combustion, everything goes to the AI instantly. So there's plenty of user cases.
So what is your vision for this? Is it ultimately that each person has their own AI that they are associated with, or what do you what's your vision for the future? You play this out, I don't know, 10 years.
Well, I believe that, yes, I think each person will have probably his AI, and this AI will follow you wherever you are, uh, geographically and also in time. And this AI will learn about you, everything, and so we'll be able to keep the continuum. So for example, the AI will know that you had a fight at home, and then when you're on your car, we'll try to make you feel better before you arrive at work, because that's where you need to be productive. Because if you are frustrated, then your productivity fell. And even if you work with other electronic devices like robots, they need to slow down because they are waiting for you. So all this, and then when you come back at home, if you have a good day at work, then you will go back to a good energy in your family. And so that's very important.
So what do you, and they might be multiple, I guess, right? But what was your initial thought process as to the primary goal, though? Is it user experience, right? Companies buying this so that the user experience in their car or with their device is better? Is it more around the emotional connection to people and making their lives better? And I'm curious, are there other business benefits that you've talked to companies about within some of these industries?
I mean, yes, I think it's everything together. You can't dissociate, them. I think you say it very clearly. It's very well said. I mean, empathy, increased customer loyalty, increased productivity. And so when you work with this, you can solve a lot of problems in different verticals. And we also believe that combining emotional states in voices is really the next big step for AI. So emotional AI with emotional text to speech are going to be extremely powerful tech.
So whenever I speak to a technologist who's doing really innovative things, at some point there becomes an issue of people's culture shift and adoption and concerns. Usually it's around data privacy and things like that. If you think about, web browsing, smart speakers, phone data, things like that. What do you hear as you speak to people? I mean, this is a very revolutionary concept. When you speak to people or companies, what are their concerns and how are you overcoming them?
Well, actually, they all have the concern of privacy, but at the end, unfortunately, they all use devices at home that are spying on them. So they are giving away their freedom and their privacy. In 2012, when we decided to create a chip, it was because we want to be on the edge. Before the edge, we understood that the thing should be on the edge because that's the only way to protect the privacy of the users. And so when our technology is embedded in product, it works completely offline. At Emoshape, we have no idea about what's going on. That's why we have clients today in the healthcare because they need to respect that privacy. And if the user accepts, the only thing that we can get is some average emotional states that the chip has experienced generated, but we don't know what are the stimulus that has created that emotional state. So the privacy, even in the most in the case where the user are allowed to share information with us, even that information is completely private because we just gather some average information about the emotional state of the device and we have no idea, no clue about how they have been generated.
Interesting. So Patrick, for anyone watching this who's interested in learning more and potentially doing business with you guys, what sort of things can they expect and how can they get in touch with you?
Well, we have an incredible team working at Emoshape. And so if they reach out to us through our website, emoshape.com, or directly to Stefania at emoshape.com, they will get instantly all the support that they need. We're really here to help our customer to get an edge and become successful. So really, we can't wait to see what our clients will create with our technology. Thank you.
Great. Patrick, thanks for being here.
Thank you. Thank you, Daniel.